Imagine pulling a rope in two directions at once. It's a bit like a tug of war, but with multiple ropes pulling in different directions. That's basically what vector decomposition is all about. It's about understanding how different forces or directions come together. Vector decomposition sounds fancy, but it's really just about splitting one vector into two perpendicular components. These components are easier to work with. Think of it as breaking down a big task into smaller, manageable steps. Each step is simpler and more straightforward. If you have a vector C, you can think of it as being made up of two smaller vectors, A and B, that are at right angles to each other. This makes calculations easier. Now if you know C, finding A and B is like solving a puzzle. Each piece fits perfectly to form the whole picture. Imagine A is how far you go east, and B is how far you go north. These directions help you navigate. Together, they get you to the same spot as C. It's like taking two different paths to reach the same destination. By breaking C into A and B, you can simplify tricky problems like figuring out forces in physics or finding direction in navigation. This method is very useful, so next time you see a vector, remember, breaking it down into perpendicular components can make even the toughest problems a piece of cake. It's a handy trick. Stay curious and keep exploring the awesome world of vectors. There's always more to learn and discover. In this chapter, we will explore more advanced concepts of vector decomposition, including real-world applications and problem-solving techniques. Imagine you're an engineer working on designing a bridge. You're dealing with forces from all directions: wind, weight, tension. By breaking these forces into perpendicular components, you can analyze each one separately, making the design process more manageable and precise. Let's take another example. Navigation. Pilots use vector decomposition to chart courses. When flying from one city to another, they break down their route into north-south and east-west components. This helps in creating a clear and efficient flight path, ensuring they reach their destination safely and on time. In sports, particularly in activities like sailing or skiing, vector decomposition is key. Sailors decompose wind forces to adjust their sails for optimal speed and direction. Skiers use it to determine the best angle to descend a slope, balancing gravity and friction. Even in computer graphics, vector decomposition plays a crucial role. When animating characters, software breaks down movements into simpler components, making the process smoother and more realistic. These real-world applications show just how powerful and versatile vector decomposition can be. By understanding and utilizing this concept, you can solve complex problems across various fields. Whether you're an engineer, a pilot, an athlete, or a designer, mastering vector decomposition opens up a world of possibilities. So, keep practicing and applying these techniques. The more you explore, the more you'll discover how vectors shape our world. Stay curious and keep pushing the boundaries of what you can achieve with this incredible tool.